Cool. Super excited to be here. Thank you for having me and all of us. It's been really great to meet everyone. I hope if I haven't gotten to chat with you yet, I hope we get to chat in the remaining hours of the day and evening. I'm very excited to share this hour with Bruno. Does this thing work? Oh, okay, cool. All right, so Robin suggested that we leave some time for Q&A. I think we can kind of play the time by ear a little. We have an hour and a half. Bruno and I were roughly thinking I'll talk for 35, 40 minutes. He'll talk for 35, 40 minutes. Then we'll do 10 to 20 minutes of group discussion. But also we can bring the discussion forward into the talk part. So feel free to just ask questions, riff, etc. The way we're going to organize it is I'm going to talk about international trade and climate change adaptation. And I guess a necessary condition for thinking about adaptation is to think about how do we think about the impacts of climate change and who they affect and how they affect people. So I'll start off with some climate impacts, then move into some international trade. I'll stop at the static models, and then Bruno will come in and do more dynamics, migration, and kind of more broadly spatial economics. Okay, so that's the outline. Okay, so I'm going to start with kind of my summary of the literature on climate change impacts. In monetary policy, I teach business cycles and macro somehow. I did work at the Fed for 3 years, which I repeat to the students every 2 minutes to try to have some credibility on these topics. I've at least seen people who work with the business cycle models a lot around at work. Okay, so in monetary policy, there's the divine coincidence, which is central bank for most types of shocks, for demand shocks. Central bank can solve the inflation and unemployment problem with the same policy instrument. So I'm kind of a riff on that. I like to call the climate impacts literature. It's the unfortunate coincidence of climate change, which is that every dimension of who is the worst affected by climate shocks is the same group of people in the world. So I'm going to put up 3 criteria and then kind of take you through some papers. So any kind of bad climate shock, it's worse if you're poorer. That's kind of a robust finding across many papers and many parts of the literature. Fewer resources to adapt. Temperature risk is nonlinear. And so if you live in a place that's already hot, it's much worse if you're getting hotter. And then the third one is it's worse to work on a farm than to not work on a farm. It's an order of magnitude worse for kind of a given temperature shock, or probably other types of climate shocks too. And then the unfortunate coincidence is the agricultural countries and the low income countries and the hot countries are all the same parts of the world. And so it would be really awesome if we had a bunch of low income farmers in Sweden and super rich people were living in sub-Saharan Africa. That would be really great for the welfare impacts of climate change. But it turns out actually everyone in sub-Saharan Africa is a farmer, and it's super hot and they're really poor. And those are all the criteria that make it worse. So I'm just going to show you a few papers about that, and then we'll move into kind of the trade section. Okay, so this is, this is biased towards my own papers, but there's also other people's papers in here. So this is from a paper I worked on about the impacts of electricity, of temperature on electricity consumption. It kind of just really shows the inequality in the world and ability to kind of cope with temperature by turning on the air conditioner. So this is in the richest countries in the world, the richest decile. This is the impact of annual temperature shocks on electricity consumption. And so you can see if it's cold, people use more energy. If it's hot, people use more energy. Okay, that makes sense. You turn on the heater or the cooler. Turns out that's a much, even if you get in the slightly less rich countries, that's a much more muted pattern, the impacts of temperature on electricity consumption. And in the poorest 60% of the world, there's a totally null effect of temperature on electricity consumption. In the micro data on AC adoption, there's a paper about AC adoption in Mexico, and Mexico is kind of around the part of the global income distribution where people start to be able to afford AC. Mexico's somewhere here in the deciles. And so you can see in all these countries that are lower income than Mexico, nobody has air conditioning. It's 2% of Indian households have air conditioning. Another stat I found that's in the slides from my macro class is only 17% of Indian children live in a house with a refrigerator, which is kind of a shocking the degree of poverty that exists in the world that we don't think about. Okay, so people don't have electricity to cope. That's one example of why it's worse to deal with temperature shocks if you're poor. People have also looked in various parts of the literature at people dying from exposure to extreme temperatures. You can see like a really hot day in India kills a bunch of people. In the United States, it like does not kill a bunch of people, even if you live in a hot part of the United States that's getting these 110-degree days, like Dallas or Phoenix. People turn on the air conditioner. It's like not good, but it's not as bad. Okay, so that's criteria 1. It's worse to be poorer. Criteria 2, you can kind of see from any paper, which is just like temperature risk is nonlinear. So like if you're here in Oslo, like the hottest part of the temperature distribution, it's like not that bad. If you're in Ghana, you're in like this green part of the temperature distribution. This is like the change in daily temperatures expected in a high warming scenario, but you're like on the super steep part of the curve. So if you live in a country where you're closer to the steep part of the curve, that's worse. Okay, and so you make these projections. This is from one of my papers about the projected impacts of global warming on people dying from exposure to extreme temperatures. It's like super concentrated in parts of the world that are hot. Okay, because they have both of these characteristics. They're low income, so it's hard to cope, and also they're already hot, so they're on like the bad part of the nonlinear temperature risk. You can do the same thing for GDP. This is the impact of like being 1 degree hotter than expected in year 0 on the trajectory of GDP over the next several years. Red is really hot country. Also, I probably should have said this at the beginning, but my strategy for this talk is like, I'm going to throw a whole literature at you because I want you to like think broadly about where you could fit in. You know, the point of this, I think the point of what Bruno and I are trying to do here is like inspire people to do their own research. So instead of showing you 1 or 2 papers, I'm trying to show you like lots of papers that we can chat about. Okay, so you can see in a hot country, 25 degrees C, get a bad temperature shock in year 0, the economy is down, and the economy like stays down for quite a while. So this is like, and then again, like a medium country, the green, the blue lines, it's like not that bad. So nonlinear temperature risk, it's bad to live in a place that's already hot. These are projections from that paper, the impacts of global warming on GDP in each country in the world. And you can see like the hotter parts of the world are expecting like 25, 30% declines from, this is from like 3.7 C. So it's like a pretty high warming scenario. Colder parts of the world, it's like not that bad because of this, in this case, because of the nonlinear temperature risk. Okay, then the third criteria, you can again look all around the literature, conditional on whether you live in a rich country. It's a lot worse to work on a farm than to work in an office or in a factory. And so this is like a couple examples from the literature of the impacts of temperature on agricultural productivity. And so this paper by my colleague Wolfram Schlenker and Michael Roberts, kind of like the OG paper in the literature. And so what this is telling you here is like a 40-degree day C, that's like 104 degrees Fahrenheit. So a 100-degree day is one single 100-degree day is knocking down corn yields in the US by like almost 5 percentage points. So that's like corn and soy are kind of well known to be like the really temperature sensitive crops. But just like keep that magnitude in mind for the next slide. 5 percentage points from a 100-degree day. That's on a farm in the US. So like a rich country with good technology. Although a complication I'm not going to get in here today is not going to get into that much today is it's not actually obvious that living in a rich country gives you better temperature effects in agriculture, because farmers might be a lot more risk averse in low income countries where they like don't have access to good savings instruments, etc. Anyway, these huge effects in agriculture. In one of my own papers, I look at manufacturing. And this graph is kind of going to show you all 3 dimensions of climate vulnerability that I'm talking about. But the one I want to focus on first here is you take the most vulnerable parts of the world, so really low income country, that's the bottom row, that's like not that hot, so not very well adapted to extremely hot days. The impacts in like the most vulnerable places of a 100-degree day on manufacturing productivity are about 0.5 percentage points. And so it's like literally about an order of magnitude across many papers is the difference between agricultural and manufacturing vulnerability. And then you can also see on this graph kind of all 3 dimensions. Temperature risk is nonlinear. It's like really, it's bad to get hotter once you're over a certain threshold. That's true across a lot of outcome variables. And you can see as you go like up the rows, living in a richer place, the manufacturing firms, like in the US, there's just an exact 0 relationship between temperature and manufacturing productivity. You can run the regression 100 different ways. There's like actually a null effect. In India, there's some effects. And then you can also see like living in a hotter place, people are more adapted to the extreme heat. Okay. So I'm running through this literature fast because I want to get to the trade stuff. That's kind of like the core thing here. But I'm motivating the trade stuff by sort of showing you these are the things across many different papers that people have found to really matter for who is vulnerable to climate change and extreme climate risk. And these things are going to point to basically like, if you really want to think about climate change adaptation, you kind of have to be a development economist a little bit, because like those are the places and people who are really vulnerable to climate change. And also like it's pretty hard to work on climate adaptation and not think about agriculture a lot. I've been joking to my friends that for years now, actually, like there's two jokes I make which are relevant to the slide. One is like, I don't understand why we have conferences that are development economics. Like that's like some small proportion of the field. Like we should have conferences that are developed economics. Like you should go to NVER or ASSA or whatever, and it's like, oh, this is like the small group of people who studies rich countries, but like everyone else studies poor countries. That's how I would organize the field. And then my slightly hotter take joke is we should have departments of non-agricultural economics, because if you marginal utility weight the people in the world, like half of them are, it's not quite half anymore. It's like around 30% of the world's labor force is in agriculture now. It was around half like 25 years ago. But if you marginally utility weight those people, and you think like utilities roughly log, like the marginal utils in the world are like all farmers basically. Okay, so take those jokes with you. Let's talk. Okay, so now I'm gonna get into trade. And I guess, one more thing I'll say that maybe should have been on the intro slide is like, Bruno and I want to tell you about a lot of papers, but we also just want you to feel like really inspired in general about economics. I think like, since this is a PhD camp, I think, it's worth thinking about like the people who I know who are the best researchers, like Bruno and Claire and Robin, and I see John there. Like people like wake up every day thinking about like problems in the world, not like, oh, how am I going to publish this paper in a fancy journal? Like you write good papers if you care about people and care about problems. Okay, climate risk. Now let's talk about trade as climate change adaptation. I'm going to try to like summarize a whole literature for you in like 15 minutes. So we'll see how that goes. So this literature didn't literally start, but I think like colloquially kind of started with this Costano Donaldson Smith paper from 10 years ago now. And this is like the super simple idea that people have in their minds, which they illustrate with this nice little example. What if like rice is really badly affected by climate change in this country and wheat is really badly affected by climate change in this country? Maybe this country can just grow all wheat and this country can grow all rice, and then there's like zero welfare effect. That's the like really simple thought experiment that they're trying to take to the data. They take this to the data for like 10 crops across 50 countries. They use this field level projected, I'll talk about it over the next couple slides. They use this field level like pretty granular pixel potential crop yields with and without climate change that the UN's Food and Agricultural Organization, FAO, produces. Okay, and I'm not going to take you through the details of the trade model. This is like more to inspire you to want to study trade than to like teach you the trade models. Although, I don't know, maybe Bruno will do some of that. Okay, so an aside, this is the data that they use in that paper, which has now been used in many papers. It's basically saying, okay, take every little parcel of land in the world. We know something about their soil. We have data sets on like soil quality, local topography, like is it sloped? We know about local precipitation, temperature, things like that. And so we're going to use like these agronomy models to project what is like the potential yield of each of, I think they have it for 38 different crops in the latest version, in each of these parcels of land. And then you can say, okay, suppose temperature and precipitation change according to the climate models. How much lower will crop yields be? An aside is like using that data in its raw form misses like a lot of what's going on with agricultural productivity in the world. So this is a separate paper by Adamopoulos and Restuccia, where they basically just look at what proportion of global agricultural productivity differences are explained by this agronomy model. And the answer is like 3 to 5%. And the reason for that is that this model like doesn't have technology and policy and institutions and all these things that we think matter for agricultural productivity, misallocation. Are people using like fancy tractors or like technology from 1850? And so this is kind of like the killer graph from that paper. The red dots are countries in the world, potential yields, GDP per capita, log GDP per capita on the x-axis. So the red dots are saying, okay, like if the world produced according to potential yields, there would be this like very tiny slope between the poor and the rich countries in agricultural productivity. The blue dots and the trend line are the actual. And so 2 takeaways from this. Number 1, it's not like geographic destiny that low-income countries are bad at farming, at least according to like the models that the scientists give us, which are the inputs to this. And takeaway number 2, if you're using these potential yields in a quantitative model, you should be careful with exactly what takeaways you're going to take away from that model, because they're missing like at least one core component of what's going on in the world. Okay. Yeah.
Technology parts. Have there been that seems that something that at least an engineering estimate or something could inform? Have there been attempts to do?
Not attempts that I'm like.
Theirs has a irrigated, non-irrigated setting.
They have irrigated, non-irrigated, and they have like high, medium, and low input. But it doesn't. It's like categorical, and it doesn't obviously correspond to like which country should we put in which bucket. It's like.
It's still hypothetical, right? They give these potential yields under this hypothetical input usage or irrigation usage.
Yeah.
But doesn't capture whether it is in reality in place or not, right? That's what you're after.
Yeah. Also, I am going to try to leave time for discussion because I realize I'm moving 1,000,000 miles an hour, which is like not necessarily that conducive to questions. Okay, but I'm already on slide 16. That's not, it could be worse. Okay, so now, just to like give you this overview of the literature, I'm gonna skip straight to the bottom line of this Costello, Donaldson, Smith, kind of like the OG paper in this literature. So they're gonna say a few things. They're gonna say, okay, this mechanism of people changing their land use in response to climate change is like massively useful for adapting to climate change. So they're gonna find that the impacts, allowing for full adjustment of land use and trade flows, there's like a 14% impact of climate change on like basically the component of welfare that is attributable to their 10 crops. If you hold fixed land adjustment, it's 3 times bigger. And so they're basically saying that's like the really big component of climate change adaptation is like people switching crops and switching land use within a country. And they're basically finding like no effect of trade. And so their bottom line, this is a quote from the paper, international trade may play only a minor role in alleviating the consequences of climate change. I have organized the first part of my entire research career around like thinking that this is like totally wrong. And so that's what I'm going to hopefully try to convince you of in the next like 10 to 15 slides. Okay, so this is the OG paper. They're like, you get all of this benefit from land adjustment within a country, trade, like not a big deal. There's like several reasons why I disagree with this bottom line. I think they probably agree with my disagreements. This is like the literature's evolved, not like we're arguing with each other. Okay. The first kind of excellent follow-up paper to this is this paper by Gould and Laborde. Another like philosophy of research aside, since this is like PhD student environment camp, and I think Bruno and I are supposed to be helping you guys like grow up as researchers, which is kind of funny because we're like barely older than you, but we're trying. Okay, sorry, the research aside, the philosophy aside, as I was going to give is like, in all the literatures that I'm deeply familiar with, like there's this famous paper, often there's a famous paper that's like introduced an exciting new topic, done a bunch of important stuff, written a really important model that people build on. It's like a really good paper, it publishes super well. And then there's like follow-up papers that are like, well, we tweaked that a little and the answer is totally different. And like no one reads the follow-up papers, and it's totally annoying to me because like you benefit so much from like the original paper that like introduces all these ideas and useful frameworks to build on. But like to get the right answer, you need to like read the whole literature and like read the papers that are in less famous journals or have not been taught as much. So anyway, follow-up paper, I think it's super compelling. They do a few things differently. They basically start with the Costello, Donaldson, and Smith framework, and they add some stuff. They have a lot more crops. I don't think that actually matters a ton to their bottom line. This is going to matter a ton for their bottom line. They're basically saying there's some places that are like actually pretty implausible to convert to agricultural land, like big forests, downtown Manhattan, a lot of other sorts of genres of that. So they filter out land that they think is like implausible to turn into agriculture. And then we're going to talk about this more. They're going to bring in like inelastic, they're going to bring in like a more sophisticated demand side, or like start to bring in the idea that it's hard to substitute away from eating, which is like not as prominent in the original paper, but we're going to talk about that more. Okay, and they're going to get, and then they're going to, and I'll explain this in a second, they're going to run like a really different trade counterfactual. And so they're basically going to get 10 times smaller of a benefit from changing the land allocation within a country. And their bottom line is like, the original paper kind of sells it as switching crops, but actually like what's going on in that paper is like switching the land within a country. Like you move your agricultural land to like a totally different part of the country. And these guys are saying, well, actually, if you restrict to like the plausible places you could put agricultural land, that effect is like 10 times smaller in their quantification. And then on trade, they're going to get an effect that's like 10 times bigger. And it's for a very simple, they do a really simple, subtle difference in their counterfactual. In the original paper, their trade counterfactual is we're going to hold fixed the share of each crop that you export. And so it's like, if I export 10% of my soybeans in the trade fixed counterfactual, I can only still export 10% of the soybeans. But what Gould and Laborde do is they say, we're going to hold fixed the bilateral import shares across countries. The key difference being the Costello Donaldson Smith counterfactual was like really about crop switching. It was like, oh, if I export soybeans, I have to keep exporting soybeans. Turns out like that didn't really matter. These guys are saying what really matters is like the geography of agricultural production. If I'm buying my soybeans from Nigeria, and I don't think they grow soybeans, so that's a bad example. If I'm buying my wheat from India, that's a real thing. If I'm buying my wheat from India, I can't switch to buying my wheat from China. In the trade counterfactual, when you hit India with like bad climate change, that turns out to matter like 10 times more. So I think one takeaway from this literature is like, I didn't put the empirical papers up that show this, but like most of the crops are pretty affected by extreme heat. And so the like, we're going to switch across crops thing seems to be a lot weaker than the we're going to switch agriculture across countries thing. Okay, so that sort of begs the question, if what really matters is like who is specializing in agriculture, then we should probably maybe have a model or like an analysis that's more about broader specialization in agriculture rather than this crop level question, which you might think, depending on how you read the literature, is like not the first order thing for adaptation. So these guys are basically saying what really matters is geography of agricultural production. This is my job market paper in which I basically tried to think, okay, what would it take to really flip around the geography of agriculture in the world? Like under what conditions could we get this story where like Sweden's farming a lot and like Nigeria is not farming? The spoiler alert is like, actually, that seems like kind of implausible. Okay, so in this paper, I'm going to take those manufacturing estimates that I showed you earlier and put them alongside agricultural estimates from the literature to do the impacts on comparative advantage across sectors. So that's step one. In step one, actually just skip forward to the next slide. In step one, I'm going to find, okay, manufacturing, the effects are like 10 times smaller. And so the impact on comparative advantage in agriculture is sort of what you would think from the impact on agricultural on absolute advantage. It's like climate change is relatively really terrible for agriculture in low income countries. So if the world specialized according to comparative advantage, you would totally get this story that's broadly the case. And in one of Bruno's papers, I think is the case in many parts of the world where climate change does really change where the farms are. But then there's this more complicated story. Actually, maybe I'll go, that's more of a bottom line slide. Maybe I'll tell the story more slide by slide. Okay, but does comparative advantage actually drive specialization in agriculture? Turns out the answer is like strongly no. And I'm going to talk about why. And when I talk about why, that's going to lead me to this bottom line where actually in this paper, the projections suggest that climate change is going to intensify agricultural specialization in those places where agricultural productivity is falling the most. It's kind of this perverse outcome where you get bad at farming and then you have even more farmers. Okay. So why is that the case? So this is what specialization, this page is going to tell you what specialization in agriculture and one measure of comparative advantage in agriculture looks like in the world. This graph on the left is basically how good are you at farming relative to non-farming across poor countries on the left, rich countries on the right. So this is like relative value added per worker in agriculture compared to non-agriculture. And what you see here is like rich countries, super good at farming compared to non-farming. And so if the world were just like your simplest Ricardian model with nothing else going on in it, you would expect to see like agricultural specialization in rich countries. And actually what you see is like the exact opposite, like the poor countries specialize in agriculture. So it must be the case that there's something else going on besides like the simplest Ricardian story in which this change in comparative advantage might move the farmers like all out of Africa, or might move people in Africa out of farming, move farmers out of agriculture. That's Bruno's territory, that's migration. Okay, so what explains this pattern? This is like the key equation in my paper, which is like a key equation in the literature. It's basically giving you the expenditure share in agriculture, this omega 8K. That's the expenditure share in agriculture in country K as a function of some fixed preference for agriculture, the relative price of food. I'm going to show you the data on this in a minute, and how rich you are. This is the real wage. And the key features here are this sigma, this elasticity of substitution. If sigma is below 1, which it turns out in many estimates, it's way below 1, then food is like not substitutable. This is like, should be very obvious. The price of food goes up, you can't just like eat t-shirts. And so the expenditure share on food goes up when the price of food goes up. That's like the first effect in this equation. And then the second effect is if you get poorer, if this epsilon A, this is like the non-homotheticity parameter for food. If that's below 1, then as you get richer, you spend less of your money on food. That's like the angle curve for food is like a very robust regularity in the time series in the cross section. So the way to explain why does everybody in a low income country work on a farm, even though they're terrible at farming, is, well, if you're terrible at farming, you're going to be really poor, and that's going to push up the expenditure share in agriculture. Also, if you're bad at farming, you're going to have a high relative price of food. All things equal, this being high, that's also going to push up your expenditure share in agriculture. So people are spending most of their money on food in these countries that are low income. Yeah.
At the risk of deja vu all over again, I thought for centuries we've been talking about structural transformation and why it's hard for poorer countries to industrialize, become manufacturing, and now high-tech services. The stories there are, multifaceted about external economies of scale and institutional change. It seems that this is a rather narrow explanation of why that is the case, rather than the broader. I'm just trying to figure out where this falls into the old debate of.
Yeah, I think it depends which part of the old debate you read. I think like this is like sufficient to explain the data. And so I guess now I'm giving you my view. My view is like, this is a model that like can match the patterns. And so it's at least a necessary condition. It's maybe not a sufficient condition for industrialization, that you either have to get good at farming, or you have to start, the rest of the slide is you have to start importing your food. So in a newer paper I'm working on that I have a couple slides on here, I basically show like every country that's industrialized, they've either gotten good at farming or they've started to import all their food. So all these other stories I would think of as like other necessary conditions. But if you're thinking about like how will climate change affect structural transformation, you don't need to go to the sufficient condition level because it already fails this necessary condition. And so that's kind of how I would think about the rest of the literature is like, suppose you get good at farming, maybe you also need all this other stuff that you're talking about in order to industrialize, but you first need the suppose for anything else to matter.
So you think the kind of agricultural revolution is a necessary condition for the industrial revolution?
That's my view. Or to import food. Like there's no country that's industrialized without either getting good at farming or importing their food. And that's almost like mechanically true because like people need food. And so you're either going to import or you're going to get good at farming. Otherwise, you're going to stay stuck.
I guess in a sense is if you can get the barriers off so you can industrialize, you'll become wealthy, then you can import food. That would be the
Yeah, I think that's fair. So that's gonna get into like the next couple slides of like, why is nobody importing food? And let me come back to that in like 3 slides. Okay, so this is like the expenditure share is super high in agriculture, but then the question kind of anticipated this. In order for the expenditure share in agriculture to drive the labor share in agriculture, it needs to be the case that domestic consumption and domestic production are really closely tied together. That turns out to be true. The stylized fact is that in the lowest income quartile of the world, 91% of all agricultural consumption is domestically produced. This is the graph from another one of my favorite papers, this May 2015 paper that kind of shows you at the time the data on that. So this is the share of spending on domestically produced goods, log GDP per capita here. This is agriculture. You can see like all of these low income countries entirely eating domestically produced food. That's not true in richer countries. And what's interesting is like the trade barriers that you need to explain this, like they aren't just the country is poor, because poor countries import plenty of their manufacturing consumption. There's like no correlation between how rich you are and your import share in manufacturing, but there's this super strong correlation in agriculture. It turns out, this is from the same paper, it turns out that's like not explainable by tariffs. First of all, the correlation with country income is stronger in manufacturing for import tariffs than in agriculture, but there's no correlation here. And it's like you get some, 0.65 correlation. There's like, it is true that lower income countries have higher agricultural tariffs, but it's like a weak relationship. And the magnitudes of these tariffs are like orders of magnitude below what they would need to be to explain a 91% domestic consumption share. So what are the trade barriers? I think that's like a big open question in the literature, but in this paper, it basically points to like these really big delays in importing. It's like the time cost is going to hit food way harder than non-food. And so like regulatory delays, lots of kind of like red tape barriers, also just like bad infrastructure, like really slow roads in landlocked countries. There's a bunch of papers that are looking at like various versions of potential trade barriers. But let me just show you a couple more facts related to this. This is from my own work in progress paper. This is just global food prices. You can do this for like a basket of foods. This is just for wheat. So it's like a totally comparable commodity. This is the cross section. You can see the rich countries here, really low wheat prices. The poor countries, in percentage terms, are like 3 or 4 times more expensive for like the same increment of wheat. And so this is kind of like also suggesting these really high trade barriers. Like you might look at the high domestic consumption share and think, okay, well, like that doesn't prove that there's a trade barrier. But this is like, well, if you could just like ship these people's wheat to these people for like triple the cost, it would literally be cheaper. And so in order to explain price differences like this, like it's pretty good candidate explanation that maybe it's like really, really hard to import food in Africa. Another way of seeing this is like you can look at the time series, and I'm actually going to run out of time for the slides where I get into like the kind of volatility consequences of this. But this is like rich countries, the time series of wheat prices. The black dotted line here, this is again from my work in progress paper. The black dotted line here is like the US export price benchmark. This is like if you go on the Bloomberg terminal, you see this black dotted line for like the commodity price of wheat. If you look in the rich countries, they're like all right on the black dotted line all the time. It like moves together. It's together in levels. It's together in changes. Like this is like how people imagine wheat as like a super integrated commodity market where everybody's a price taker in like this global integrated market. But as you go to like upper middle income countries, you can see that like starts to break apart some. The lower middle income countries, it breaks apart more. You go to low income countries, they're like, first of all, like massively higher in levels. And also like what is going on and changes. There's like no correlation between what's going on in rich country price movement, or no correlation is like a colloquial exaggeration, but you can see those lines are kind of just going all over the place, not following like the global integrated market for wheat. And so this is kind of like more on this topic of like, it's really hard to trade food in poor countries. And that might be part of why they're stuck farming. I'm gonna show you a couple more things and then maybe I'll like skip my last section and hand over to Bruno and. Okay. And so this paper I wrote would suggest two things. It would suggest number one, if lower income countries were able to trade more like richer countries, climate change might be a lot less damaging there because then you would get some more of this reallocation. They might switch to importing more of their food on the intensive margin and like reallocate activity towards other things. I think this is where like the caveat John was talking about is like really important. I think you can think of this, I think it's like pretty robust to think of this as like a necessary condition for climate change contributing to industrialization or industrialization to happen more broadly. Like either you get good at farming. This is like a scenario where people stay bad at farming because climate change hits them really hard. But maybe for it to be a sufficient condition, there's a bunch of other stuff that's like beyond the model that you need to industrialize. Okay, and then the second thing it would suggest is like, suppose it remains really, really hard to import food in poor countries. Then as agricultural productivity gets hit by climate change, maybe more people are going to be stuck farming. So I wrote the first draft of this paper in 2019, and it's been a few years since then. And agricultural productivity in like the last 7 years, basically, in sub-Saharan Africa and South Asia has like stagnated completely and like gone down a little bit. And also, you can see this like time series. I was born in the year before this graph. Like my entire life, in like every, all of low-income countries, the agricultural employment share has been going down, 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 down. This is like, when I was born, 68% of people in low-income countries were farmers. Now it's like down to 50-some%. You can see like over the last 6 years, as agricultural productivity has stagnated, so has the movement out of agriculture, which might cause you to be concerned in the long run, or hopefully it's just like a blip, we had COVID, et cetera. Okay. I'm going to cover a few more slides and then hand over to Bruno. So that's like trade on the output side. The low-income countries seem to be super disconnected. They're not importing food at all. They're really bad at farming. Maybe that's a problem for the impacts of climate change. There's also like really good work that's never been more topical, I think, than this summer on the impact of trade and agricultural inputs on agricultural productivity, which I also think of. These are not papers explicitly about climate change, but I think of them as like very central to the climate adaptation literature, because I'm taking the literature as like anything that matters to like developing country farmers matters for climate change adaptation. Okay, I didn't expect to get so sweaty while presenting. Just like too excited. So this Farocchi and Pellegrino paper is basically trying to quantify the impact of trade and agricultural inputs. So I'm going to show a few things. First, this is just showing to the point about the agronomic projections have a weak correlation with true agricultural productivity. This is showing you maybe why. The inputs of fertilizer, I guess this just has fertilizer, but agricultural inputs more broadly just like scale really strongly with country income. The rich countries are very input intensive. The poor countries are very labor intensive. And what Farocchi and Pellegrino show is that trade is like super essential for that. The average country is importing 65% of their agricultural inputs. It's kind of surprisingly consistent across types of inputs. 67% of machinery, 69% of fertilizer, 69% of pesticides. Basically everybody's importing most of their agricultural inputs. And so this trade on the input side is going to matter a lot. They also show, this is very relevant to the news right now, these input exports are super concentrated. So the top 10 exporters account for 82% of all fertilizer imports in the world. I think actually like you could do top 4 and it's like pretty similar for fertilizer. And now of course, like we have this terrible fertilizer cutoff. Okay, so Farocchi and Pellegrino are going to do a few things to try to connect that to trade. They're going to show in the cross section that regions closer to the trading hub in their country adopt many more of these inputs. So if you're like close to wherever you can import in your country, you like use more fertilizer, more pesticides, more machinery. And then they're going to show in the time series that countries that liberalized trade earlier started to use agricultural inputs kind of like corresponding to when they liberalized trade. So I think they have like some good circumstantial evidence that backs up their model counterfactual that basically shows that I'm forgetting the number, but like a huge percentage of agricultural productivity in the world is dependent on the trade in these inputs. Then there's like a natural experiment that kind of like makes this point in a nicely well-identified way. So the Farocchi and Pellegrino paper is saying, okay, we think trade and fertilizer and other stuff like that is really important for agricultural productivity. Turns out like 5 years ago, Sri Lanka decided to run, I think, a very poorly conceived experiment to try to prove this point, in which they banned all chemical fertilizer inputs. And so these co-authors, Ghosh, Fraga, and Fernandez, basically look at what happened in Sri Lanka in response to this ban on fertilizer inputs. It's like the most important set of graphs in the world right now, because like something like 30% of global fertilizer is not getting to its destination this summer due to the closure of the Strait of Hormuz. Okay, so Sri Lanka, rice yields, this is like rice yields, and then this is the year they banned the fertilizer. It's a huge decline in yields. Okay, they talk about they imported more rice. This is like literally outside the confidence interval, the historical period. And to try to show that like the fertilizer was really essential, they produced this graph, which is like almost like you couldn't have faked this graph to look any more convincing. On the x-axis here is the crop's fertilizer intensity, and on the y-axis here is the change in that crop's, I guess here it's export value, maybe production would be the more natural statistic, in the year of the shock. And you can see like the more fertilizer intensive crops were like systematically the ones that got crushed in 2022, or is it 21, whatever year it was. Okay, so this is like good kind of quasi-experimental evidence on, unfortunately, I think what we're about to see play out in the world over the next 6 months. Okay, do you think I should hand over? I think I should
take more minutes. No, we can adjust.
Okay. Well, I feel bad because I'm eating into Bruno's time and I want to leave time for.
I also want to see that. Don't worry.
Okay. Okay, well, I'm just going to present 2 more papers. I only have a couple more slides. So a lot of the papers in this literature I've talked about are doing like kind of a dissatisfying thing, because it's like a steady state counterfactual versus a comparative static that's like another static steady state. Bruno's going to like do one dimension of improvement on that by adding dynamics and kind of like more like richer representations of space. But another thing you might worry about is like, what if climate change is like really bringing volatility, and like sometimes you get a terrible shock, and just comparing averages across counterfactuals is like actually not that satisfying. And so in this paper that there are 2 papers on the slides that I've not yet written, but have a bunch of results. We're basically looking at how do countries respond to agricultural productivity shocks from climate change, and how does trade policy mediate that? And so I'm just going to show you like 2 graphs and try to tell the story in words. So we're going to basically look at what is the impact of like extreme heat on, it's really bad for crop yields, makes sense. It raises food prices a lot. The magnitude on this is like 100 killing degree days is about 2 standard deviations in sub-Saharan Africa. That's going to increase the food price index. So this is the food CPI by about 9 percentage points. And so it's like 2 standard deviation bad crop yields, like a 9-10% increase in food prices. We can show that's like 3 percentage point increase in the number of people experiencing food insecurity. Okay, farmers are going to plant more land in response to this bad agricultural productivity shock. But then this is the part that we're like really focused on in the paper. So countries experiencing a bad agricultural productivity shock increase agricultural imports by a lot. That makes sense. It's like conditional on being able to import. You know, all the countries are in the sample here. So this includes countries that are more trade integrated and less. So you import like a lot more food, 11% point increase in food imports. But you basically, any way you run the regression, you never add a new import source. And so this is like, did I add a new source country that I was not previously importing from? And the answer is no. And if you look at like just the 7 major crops, the answer is still no. These are T statistics, so we can rule out even like 1/10 of the time you added a new source, kind of statistically significantly. And so our takeaway here is basically, we show this in many ways in the paper, the countries that are more diversified across agricultural import sources, like countries that they import from, are able to scale up their food imports much more in response to a bad shock, and therefore suffer much smaller domestic price increases, because they have like this option value of a bunch of different countries. Like somebody had a good year when you had a bad year. And so this is basically, you can look at like the heterogeneous treatment effects of food price impact from a given heat shock. And you can see like in the least diversified, this is conditional on being a low income country. So this effect holds like, it's not just that poor countries are not trading, it's like conditional on if you're low or middle income, how diversified are you? And the other thing, I don't have time to kind of show you all the results, is like, this is actually like surprising. This measure of how many different sources you have for each type of food is surprisingly uncorrelated with like the import penetration rate. So there's some countries that are importing a lot from like a couple of countries, and some countries that are importing a little bit from many countries. And we're saying it's like the latter group that has like much more stable food prices. And so what this coefficient is telling you is like the food price impact of 100 killing degree days is like 23 percentage points in the least diversified low income country, but like not significantly different from 0 in like the most diversified country. Okay. And then so this is going to suggest, kind of consistent with some of the other graphs I showed you, that there's like a lot of segmentation in global agricultural markets. They're not actually moving together across different types of countries because it's really hard. We think for like regulatory reasons, it's really hard to switch your food sources in real time. It's like a lot of import licensing. It takes like years to come to trade agreements where you can like import food from a new different country. And so we can see after the war in Ukraine, what this graph shows you is basically the countries that were importing from Ukraine experienced like a relative doubling in wheat prices compared to countries that were not importing from Ukraine. And of course, if the market were like perfectly integrated, you would expect like these coefficients to be 0 because everyone's getting the same price shock. And this is like the relative effect. And so we basically think like global food markets are extremely segmented, and it really, in order to like reduce your volatility, you want to be integrated with like more parts of them. And then I'm going to skip the last paper, but there's this cool Shao, Moscona, and Sastry paper that shows that tariffs, taxes, and subsidies, and I guess especially like border policies, are going to also respond to extreme heat, and countries are going to do a lot to try to protect their consumers in the face of these shocks. And so if you're worried about kind of like volatility and food security, you need to worry both about policy, both about like productivity volatility, but also like policy. It's going to be endogenously volatile too. Okay, I'm going to stop talking now and maybe just leave this slide